All right, so this picture is on page 250, and you're copying that picture down for me. All right. These are quadratic graphs. What makes a graph quadratic? What exponent? To the second power. Absolutely correct. So it's the exponent to the second power that makes it quadratic. Now, this specifically is in what we call standard form. We call this standard form, and that's important because we're actually going to learn a different form as well in a couple weeks, in about a week or so. But this is standard form. We like standard form. It's very helpful. It's very easy to use. It's pretty. We like it. Okay? Standard form has a couple key points to it. It's got an A, a B, and a C. What is the A, B, and C? What do they represent? Not sure? Okay, C is the Y-intercept, and that's good. I'm going that way, but I guess that wasn't really the question I was asking. What are you going to see on an equation with the A and the B and the C? What takes the A and the B and the C's place? Just numbers, right? Somebody said it. They're just numbers. Okay, these are the coefficients of x squared. You actually have three different parts to a quadratic. You've got this part, and this part, and this part. Okay, ax squared, and bx, and c. Do you remember those just from a week ago? Ax squared is basically the parent graph of all quadratics, isn't it? So that's a quadratic. Bx is basically the parent graph of what? It's not quadratic, it's linear. Yeah, it's linear. And then C is basically the parent graph of what? Uh-oh, we struggled with that. Somebody got it. Constant. Okay, so the ax squared is a quadratic term. The linear term is the bx term, and the constant term is the c. Okay, just to recognize those. Now, we're going to talk about this first one. Tyler already gave it to us. The y-intercept happens. The y-intercept happens. All of these points that I drew are on the y-axis, right? Okay. What does every point on the y-axis have in common? It's a little hard to read up there. Ooh, definitely don't want to do that. Oh, don't do that either. Come on. Go away. What's true about all of those points up there? They all have zero where? Yeah, all the x's are zero. The y-intercept happens when x equals 0. Always. You can find that on any graph in the whole world from now until eternity. If you want to know where that graph crosses the y-axis, you plug in x equals 0. Works on linears, works on everything. Everything you could possibly ask for. So, I'm going to plug in x equals 0. Well, look, they did that right here. Okay? They did that right here. They plugged in a 0. What's 0 squared? 0. 0 times a? Also 0. They plugged in a 0 right here. What's 0 times b? And then I've got 0 plus c. What's 0 plus 0 plus c? It's just c. So what does that tell us? It tells us that the y-intercept is c. Okay? In the equation, if you're in standard form, the y-intercept is c. The next thing that you notice is this quadratic is symmetrical. What does symmetrical mean? It's the same on both sides, right? So you could fold it on itself and it would trace itself over. So it's symmetrical. Well, that axis of symmetry is super important, and that's this equation right here. And you can see it's written down. So we got to know the axis of symmetry. So make sure that you have that written down somewhere. It's x equals negative b over 2a. And where does the b and the a come from? Comes from the a x squared and the bx up top in the original. So those coefficients. You should have done this a little bit last year. I guess that's about it. There's one more thing I just want to mention, and that's the other name for this. All quadratics have another name. They're called parabolas. Parabolas. All right. So recognize that name. Parabola. A lot of people will call it. It's a parabola. Okay. Parabola. It comes from a conic section. We'll hopefully get a chance to study that a little bit later in the year. Any questions? Just basic information. All right. Now we're going to use it. We're going to graph. So you need to. think I told you got graph paper. You need to use graph paper is where we're going to be. All right. First thing I notice, what's different about the equation that they gave me? It's switched around. Can I rearrange that if I want to? Sure can. I'm going to rearrange it to x squared minus 4x plus 2. Make sure you keep the sign of the number that was in front of it. And I'm going to use y equals instead of f of x. It's the same thing. All right. Now, identify the a, the b, and the c. Say that again. Okay, somebody said about the x squared. What is that? Okay, it is the a, but it's actually not the x squared. It's actually the number in front of the x squared, which is, come on now, 1. Okay, it's a 1. And what number is the b? All right, -4. I should have put a, sorry. And then this is b. And now what's the c?
2.
The c is a 2, all right? And I'll switch colors for you there because that's important. I love C. What does C tell me? The Y-intercept. So right now the Y-intercept is C, which is positive 2. I can go to my graph paper right now if I need to and graph C equals 2. There we go. Now I'd also like to find the equation of the axis of symmetry. The axis of symmetry is important because that's right down the middle of the thing, right? The axis of symmetry has its own equation. What is it? Okay, so the axis of symmetry has its own equation. It's x equals -b divided by 2a. Now I need to know b and a, and I can figure this out, right? So what's the b? -4. So I'm actually doing -4. Is that right? Okay. Divided by 2 times a. A was a 1. Okay. So that gives me on top, -4 is really 4. Divided by 2, 4 divided by 2 is 2. So my axis of symmetry is at x equals 2. Now I don't have to draw this on the graph, but I like to do it just because it kind of shows me where I'm at. That's right along here. That's the axis of symmetry. I got a little sloppy there, but. Okay, so that's the axis of symmetry. Now here's the important question, okay? The axis of symmetry, I didn't mention it before, but the axis of symmetry is at 2, and then it asks you for that x-coordinate of the vertex. Where does the vertex happen? Where does the thing change directions? It changes on the, not necessarily on the y-intercept. That's a good guess. Here, I'll draw one off to the side here. If I'm just looking at any old parabola, whether it goes up or whether it goes down, the vertex is located at the very bottom or the very top, right? So if I'm coming down, 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 I get to the vertex and I change direction. What else happens right at that point? What happens right here? What did we call that thing? What do we call that? That is the axis of symmetry. That's exactly right. That's the axis of symmetry, which we just found out. Thank you. We just found out that axis of symmetry. So the x-coordinate of the vertex has to happen right here at the axis of symmetry. So my vertex is going to be 2 something, right? Now, here's the question. What's the something? How do you find the y if you already know the x? Somebody said it. What do you do? Okay, well, I could do that. That'd be a little complicated. If you know the x, what does this equation up here tell us? The y. So what should I do with the x? Plug it in. There's what I was looking for. You plug it in. So my y is going to equal, I just got to plug in a 2. Let's see, that's 2 squared minus 4 times 2 plus another 2. Let's see, I can do that mostly in my head. 2 squared is 4. 4 times 2 is 8, so that gives me 4 minus 8 plus 2. What's 4 minus 8 plus 2? Negative 2. So the y is negative 2. So I can actually go to the graph now and put 2, negative 2. Let's see if I can get that right. There. Come on, baby. Doesn't want to graph it for me. There we go. There we go. So now I know the vertex. Give me one more point, and I can have a good graph of this. Can anybody give me one more point? I know the y-intercept. The y-intercept is 0, 2. I got that already. 4, 2. What about 4, 2?
It's the other side.
All right. It's a reflection, right? Remember, this is symmetrical? So what they just did was they just thought about the fact that this is symmetrical, right? Here it's symmetrical, right? So if this is 2 to the left of that line, if I go 2 to the right of it, the point 4, 2 would be on my graph. So that's exactly what I'm going to do. I'm going to go to 4, 2, draw a little point, and hopefully you'll make a better looking graph than I did. That's our parabola. Any questions so far looking at that? The process? I know you're a little behind. All right. All right. 2 other things I might possibly ask you. I might always ask you about domain and range. What would the domain of this thing be? All real. Very good. All real numbers. And the range is everything, every y greater than or equal to negative 2. It's the very bottom, that very minimum value, right? All right. Nice job. Okay, technically it looks easier, but it's actually not easier because they gave you less information. I would rather have more information. Is this standard form, negative 4x squared? It is, but where's all the information? Y equals negative 4x squared plus 0x. Very good. Plus 0. The other 2 terms, the b and the c, were both 0, which made it look easier, but actually it was a little more complicated because I had to think about it a little bit more. But that's okay. Find the y-intercept. How do you find the y-intercept?
0.
All right, that's your c, so it's c equals 0, so I know it. I'm done. As far as the y-intercept goes, I got that. Come on, baby. Got it. All right. Find the axis of symmetry. How do you find the axis of symmetry? All right, you have to use the equation, right, for the axis of symmetry. So that's going to be x equals negative b over 2a, which in this case is going to be negative, what's the b? 0, divided by 2 times a, which is negative 4, which is 0 over negative 8. It's just 0, right? All right, so this thing, oh man, the axis of symmetry is actually the same thing as the y-intercept, isn't it? Well, that is good, but it's also bad, because what that does is it messes up. Oh, I graphed that in the wrong spot. Who was going to correct me? Nobody's going to correct me? Look at my y-intercept. See it? Wrong spot. My fault. It clearly says 0, and I just put it in the wrong spot for no good reason. Let's put it there. There. Sorry about that. All right. That's a good thing and a bad thing, though, because what's it look like? You know, earlier you guys told me about using symmetry to help you find a third point. Like on the other problem, we had a y-intercept and a vertex. We had 2 points. You used symmetry, you found me a third one, and boom, we had a graph. Now I only have 1 point. How can I get another point? How have you always graphed things since the very first time you ever graphed an equation? Really? How do you graph it? Yeah, we just need to make a table. We need to make a table. But the good news is we know where to start, right? That 0 right there, that axis of symmetry, I know that's 0, 0. Hey, now I know that a couple of the points are going to be to the left, a couple points will be to the right. They'll match up perfectly, right? So all I got to do is pick a point. So pick any point that you think will be easy to plug in, any number below 0 up here, or any number above 0. Pick a point. Choose an easy one. Choose 1. Why not, right? Plug in a 1. So let's see, that's negative 4 times 1 squared is what? 1 squared is 1. 1 times negative 4? Negative 4. That answers negative 4. Right? Now what was the special property? Let's see, that's 1, negative 4. It's down here. I'm going to go ahead and graph that, maybe. All right. What was the special property I needed to know? The axis of symmetry. So if that's negative 4, isn't this one also negative 4? Yeah. Now do you have enough to make a pretty graph? I think so. So that gives me this one, and it's pretty steep, and hopefully you made a better graph than I did. But there you go. What's the domain and range? Domain is all real numbers. Is that true for all quadratics? Yes. And the range is y. Are they greater than 0? No, they're less than, aren't they? Less than or equal to 0. So that's your domain and range. All right? Questions?